Hi everyone, welcome back. In the last video, we looked at how a charge moving through a magnetic field, that is perpendicular through that field, experiences a force. Okay, but we didn't talk about the direction of the force. Okay, and it's not exactly clear or apparent what that direction is. Okay, note we're not talking about magnets in a magnetic field. We're talking about moving charges in a magnetic field. So it's not necessarily the fact that these charges are going to follow the field lines. Okay, something else happens. So we're continuing with this dot point. Okay, we're still going to be using F equals QVB. We're just now going to be talking about the direction of this force. So just like we have a rule that you can use your hand for to determine the direction of the field from a current in a wire, we've got a rule to determine the force that a charge would feel if it was in a magnetic field. Okay, and you can see the pictures here. We call it a slap rule, okay, for the reason that when you open up your hand, your palm acts as the direction of which the force will be applied. Okay, so you can think of your hand as slapping the charge to move in a certain direction. All right, so as indicated by this picture here, if we're talking about positive charges, and this also includes current in a wire, then your fingers are the field lines, the magnetic field lines. Your thumb is the direction that the charge is moving, and your palm indicates the direction of the force that this charge would experience. Okay, notice that when you open up your hand like that, your thumb and your fingers are they necessarily have to be perpendicular to each other. Okay, so this only works, remember, when charges are moving perpendicular through a magnetic field. Okay, so with your right hand, that is used for positive charges and conventional current. If you're talking about negative charges moving through a field, then you just swap hands. Okay, you use your left hand. Okay, because negative and positive are opposites, left hand and right hand are opposites as well. Okay, but the same things apply. Okay, your fingers indicate the direction of the field, your thumb indicates the direction this negative charge is moving, and your palm indicates the direction of the force. Okay, if you can't configure your hand in this way, then it's most likely that the particle is not going to be experiencing a force. Okay, so take for example a particle that's moving parallel to the field. It's not possible for you to really make this hand gesture if that's the case. Okay, your thumb needs to be perpendicular to your fingers in order for this to work. Okay, which indicates that the charge needs to be moving perpendicular to the field in order for this to work. Okay, so slap rule, used to determine the direction a moving charge will experience a force if it's moving through a magnetic field. So let's do a question. A single positively charged particle with a charge of fundamental charge 1.6 times 10 to the negative 19 coulombs travels at a velocity of 10 meters per second east, perpendicular to a magnetic field of strength 4 times 10 to the negative 5 teslas, whose field lines point north. What is the direction and the magnitude of the force on the particle? Okay, so magnitude, we can work that out. That's just F equals QVB. All right, so Q is the size of the charge. So 1.6 times 10 to the negative 19 times its velocity, so 4 times 10 to the negative 5 multiplied by the, that's the field strength. The velocity is 10. That's okay, we'll just write that at the end. And if we multiply all that together, which I haven't done, so let's work this out together. 1.6 times 10 to the negative 19 times 4 times 10 to the negative 5 times 10. And we end up getting 6.4 times 10 to the negative 23. Oops, what am I doing? 6.4 times 10 to the negative 23 newtons. All right, cool. So magnitude's pretty easy to work out. What is the direction of the force though? Okay, well if we draw a diagram for ourselves, so let's say north is this direction. And these are the field lines, the magnetic field lines that our charge is moving through. And our charge is moving to the east, which will indicate this blue arrow here. Okay, so which direction would this charge experience a force? Well, it's a positive charge as indicated by the plus sign in our question. So we use our right hand slap rule to determine that direction. So make your fingers, do it right now. Put your hand right in front of you. Make your fingers point in the direction of the field lines. Make your thumb point in the direction of the charge's velocity. And your palm should show you which direction the force is going to be, which, according to our diagram, is going to be out of the page. Okay, so I'll make another color indicating the force is going to be out of the page. Cool. There you go. That's all it is. Just using your slap rule to work out that direction. Okay, well, that's it for this video. Short video, just showing you how to work out the direction of this force. And it's not too crazy. Okay, just remember for positive charges and conventional current, you can use your right hand. If it's a negative charge, you just use your left hand. And that's it. All right, I'll see you next time.